Hey, this is Linda Noss, and I wanted to show you how to do a bubble sort today. A bubble sort is probably one of the oldest sorts. It's not the most efficient, but it's one of the easier ones to learn, so I thought it'd be a good starting place. I found on Wikipedia they have a really nice explanation of a bubble sort right here, and I just wanted to show it to you. They tell you about the performance. There's a little animated piece over here. It kind of shows you how the bubble sort's working. It talks and then it takes an example and shows you step by step about the pieces that are switching. So essentially the bubble sort takes the largest item and it pushes it to the top. In this example, the 8 is already the largest and it's already at the top. So it's taking the 5. On each pass, it's moving the 5 up one more space. So the 5 is bubbling to the top. That's why they call it the bubble sort. And then on the second pass, it does it with the 4 and so on. Another thing the Wikipedia site has here, it has the kind of a pseudocode. I think this is C or C++, but it kind of talks about how to do the implementation. So what I want to do today is I kind of want to go through the bubble sort with you. So I bring you clips up here. And you can see I've already written it, and when you run it, it does basically what the Wikipedia example showed me. But let's go through and do this from scratch. So I'm going to call this just BS2, bubble sort 2, and hit finish. Okay, so basically the first piece of the bubble sort is the fact that you want to swap things. So if you get two items and they're not in the right order, you need to swap them. So I'm just going to create an array here. And I'm just going to give it 3. 1, 2, 3, 4, 5, 6. So we're just going to use 1 through 6 here. And then I'm going to create a temporary variable because when you swap two things, you need to have a temp. So I'm going to go ahead and do that. And then essentially, if two items are out of order, you want to flip them. So I'm just going to start with the first two items, the 5 and the 2, which is array sub 0 and array sub 1. So I'm just going to basically say if array sub 0 is greater than array sub 1, then we want to swap them out. Sorry, wrong thing here. So we set the temp equal to the first piece. We set the first piece equal to the second piece. And then we set the second piece equal to the temp. And this, using the temp allows us to keep all our information. If we just said array sub 1 equal to array sub 0 and array sub 0 equal to array sub 1, we would actually lose a piece of information. So anyway, here's this. Now I want to make sure that this works, so I'm going to put a little loop in here. And I'm going to go up here, I'm going to declare a variable I. I'm going to start this at 0, length, and then I plus plus. And then I'm just going to do and I'm going to print out I. I'm going to tab them. I'm going to have a tab, so there's a little space in between each item. And basically save. If I've done this right, you'll see down here at the bottom, I started out with a 5 and a 2 up here, and this little piece of code flipped the 2 and the 5 around. So now they're in the correct order, but you'll notice that nothing else is. So the next thing we have to think about is, okay, so the 5 and the 2 are in the right order, so how am I going to get the 5 and the 4 to flip, and then, well, the 5 and the 6 won't need to flip, but so forth and so on. So the next thing I have to do is I have to think about how the next piece is going to be. So I could say here, I could just take this piece right here and and go like this, and then just switch this to 1 and this to 2, and so forth and so on. I could make all those changes in here. Actually, I only need to do this, don't I? And so then when I run this, the 5 is moved up yet another piece, and then I could go on and do the next one, and the next one, the next one. I could do this 5 times because there are 6 items in my list. Unfortunately, that's not the most efficient way to do this. If you had 1,000 items on your list, you certainly want to do this 999 times. So we have to put this in some kind of loop to make it happen efficiently. So what I'm going to do is I'm going to take this entire piece right here, and I'm going to put it inside a for loop. And I can use I again because this for loop is completely separate from that one. Okay. And then I want to say I. Now typically what you do is you'd say length here, and I'll put that there for now, but we'll discuss that in a moment. And then I want to put this whole thing inside, so I'm going to tab it all in so you can see how it's put together. And of course, now that I'm using I can change the zeros out to I's. And I really want to compare the 0 with the 1. So the first element, which is 0, with the second element. So, but then I want to compare this second element to the third element, and the third element to the fourth element. So it's just going to keep moving up and around. So what I really want to do is I want to take the I element and compare it to the I plus 1 element. So I'm going to go ahead and change that out here. So now we've got the I plus 1. Now when I run this, I will get a out of bounds error, more than likely. Yes, that's because I'm going to the length of the array, and when I is equal to the length of the array, I plus 1 is equal to 1 more than that, which is out of bounds. So what I have to do is I have to subtract 1, because I really don't want to go all the way to the end of the array. So here we go. So now you can see that the 2 and the 4, it switched twice because the 5 is up to here. But the 6, notice what's happened with the 6. The 6 is the largest value in the array, and the 6 is now in the correct place. So I've gotten one element into the correct place. So what I can do is I can go ahead, again, now I want to get 5 in the right place because I want 5 to be all the way up to there. So what I'm going to do is I'm just going to take this for loop, and I'm going to copy it. Instead of length minus 1, I'm just doing length minus 2. Oh, save. And now I'm going to run it, and you'll see now the 5 is in the right place. And then I can do this. Now I want the 4 to be in the right place, so I'm going to go ahead and do this one more time. And the 4 is in the right place. Hopefully. Yep, there it is. Now again, you can see the pattern, and because I have 6 items in my list, I could do this. But what happens if I have 1,000? Then I'd have to have 1,000 of these entire loops. So what I want to do is I want to come up with a better way of doing that. So the next thing I'm going to do is I'm going to say, well, I want to keep going until everything is in order. So if I go through the entire array and I don't use this algorithm at all, if I don't switch anything, then I know that everything's in the right order. So what I'm going to do is I'm going to create a Boolean variable up here, and I'm going to check to see if any switches have been made. So there's my switched, and then I'm going to set switched equal, I'm going to put a do loop here. I'm going to keep doing this until it's in order, or while it's not in order. So I'm going to say while the array is not in order. How do you say this here? Well, switched is going to be equal to false to start with, because right now at this point in time, let me just tab all this in so you can see that the for loop is inside the do loop. I think I want to actually move this up to here. Okay. So I want to set switched equal to false to begin with, because at this point in time I haven't switched anything. The computer coming down the pike here, it starts here and initializes and hits the do loop, and at this point I haven't switched anything. Well, if I do switch something, then I switch the Boolean to true. Okay, and then I can just say while. Now, the while loop will continue to go while I haven't switched it, while switches have been made. So while switched. So while the condition is true, if switched is true, I want to keep going. So while switched. So as long as I have switched something, that means it wasn't in order, and I have to go back and check again. So basically what this will do, hopefully, unless I've forgotten something here. Oh, I have an error. Switch. Oh, I need a semicolon here. Sorry. So then you can see it puts everything in order nicely. Isn't that beautiful? And then we're going to just try this. Try adding some other numbers in here. And just see if it works still. There it is. Everything is in order. So in order for you to see how this worked a little bit better, I would like to put in a few more things. First of all, we're going to be discussing how loops are efficient or not. So I'm going to put in a little integer variable here. It's going to count the number of times I've actually swapped the numbers around. And so when I actually swap the numbers around here, I'm going to add one to my counter. And then at the end of my loop here, I am going to print out the number of swaps. Where's my loop? Okay. System. Let's put swaps. Okay. It's nice to label it. There we go. So there's that. So now I can go ahead and run this, and at the end it says I swapped 17 times. I'm just going to put a little backslash in there so it's on the next line. There it is. Now, if you want to know what's happening in each loop, you would take this for loop and you would put it in here, so we can see actually what's happening after each time it goes around. So we get this long line of stuff. So what I really want to do here is I want to add in a new line. I don't know if I want to add it there. That's not where I want to add it. I want to add it I would need a carriage return right here. A carriage return I can get just by saying print line instead of print. So there's that. Space it out a little bit for you. Okay, now we can go back and look at this. and see how each thing happened. The 345 was sitting here originally, and you can see on the first pass through the 345 is pushed to the top. The 34 is pretty much already in place, so that stayed pretty much there and nothing else. There's a few other swaps that happen here. The 2 you'll see is working its way down to the bottom. Okay, so then we go to, and you'll see that the next one, the 9 is put in its place. It's already there, not very exciting on that one. And then the 6 is put in its place, so the 6 moves up. And then the 5 is put in its place, and the 4, the 3. And all the rest were in the right place, so 17 swaps. Now if I move stuff around a bit here, say I put the 9 down here, take it away from up here, and maybe put the 34 down here. Okay, you'll see the swaps probably will change. There you go. So essentially that's how that is working. You see the -2 works its way down, little by little. So essentially that is how the bubble sort works. Thanks, and we'll talk to you next time.